Myself, Prabhas Singh, Assistant Professor from ABES Engineering College, Ghaziabad. Today, we will discuss about Floyd warshall algorithm in this lecture. This is the all-pair shortest path algorithm. Now, what does the mean all-pair shortest path? It means that finding a shortest path from every vertex U to every vertex V is called as a all-pair shortest path from every vertex U, every U to every V. Now, what is a Floyd-Warshall algorithm? It follows a dynamic programming approach to find the shortest path. The running time complexity of this is order of V cube or order of N cube, the number of vertices. Negative edges may be present, but negative cycle must not be there as Bellman-Ford algorithm. Negative weight edges can be present, but negative weight cycle cannot be formed, and we follow a dynamic programming approach for this. Now, as we all are aware that there is a 4 step which we have to follow while solving any problem using a dynamic programming, out of which the first step is characterizing the structure of optimal solution. Now, in this step, it is very simple. Let's suppose if there is a directed edge from I to J, then we simply write a weight, let it be 5. Then we simply write that is I to J edge is carrying a weight 5. But when we are carrying from every vertex U to every vertex V, then there may be a possibility that there can be a path from I to K and then K to J with weight 2 and 1. That is, after an intermediate vertex K, the path to I to J is updated with a minimum weight 3. In this step, we are thinking about, let's suppose K is not an intermediate vertex. If K is not an intermediate vertex, then we simply write the weights as this. If K is an intermediate vertex, then what we have to do is, if K is an intermediate vertex, then what we have to do is we simply see I to J, J to K, K to J, then K must be using a shortest path through this. So we will be printing K because we are coming to J with the help of the K. Now, moving ahead, we will see this. Let's see I to K and K to J. And this is a path. What we will do here is all the intermediate vertex can lie in between this. I to K. There can be multiple intermediate vertex. There can be a possibility that we are having a path 1 to 2 with 5. But then there can be a possibility that we can come from 1 to 3, then 3 to 2 with 2 and 1. There can be a possibility we can come 4 and then come here with 1 and 1. Right? 1 and minus 1. There can be a possibility that there will be multiple intermediate vertex between this. There can be a possibility that there will be a multiple intermediate vertex. Now, what we have to do is, when there is no intermediate vertex, what will be happening is we are coming via A. When there is one intermediate vertex, what happening is we are coming via this. When there is two intermediate vertex, we are coming via this, then we are coming via this. So we have to represent or return a immediate successor node to a destination that will help us to understand from where or which path we are following. Now, this is the recursive formulation, that is Dijk. Now, what is Dijk? This Dijk or dk. This is shortest path weight, distance from vertex I to vertex J with the help of intermediate vertex K. Up. The problem is divided into two sub-problems. If K equal to 0, that is no intermediate vertex, we simply write the weights of the graph. If k greater than equal to 0, of k greater than equal to 1, then this is happening. This means that I to j or I to k via j. So what we are doing is this previous value, that is dij k minus 1, comma, previous value of dik and dkj sums up to whatever the value it comes, we have to compute it the minimum value. What is the minimum value of what? Dij, that is the previous one, and dik k minus 1 plus dkj k minus 1. We simply get the minimum of this. This recursive formulation which we have to follow while solving any problem using Floyd warshall. Now this is the algorithm. If we simply see this algorithm n representing rows of W, or we simply say that number of the vertices. D naught is representing the W. What we have said is, if k equal to 0, then we simply say dij0 will be representing wij, and this d0 is representing W. If this is a for loop which we are running for the intermediate vertex, and this is a dependent loops of I to j, that is vertices. What we are representing is, if k greater than equal to k greater than 0, then these are the conditions, and we simply get this. And the running time complexity is n cube. And now step number 4. We have seen first step characterizing the structure, then we have seen the recursive solution, then we have computed an optimal path. Now we are seeing constructing a shortest path. Now, while constructing a shortest path, two things must be kept into the mind when k equal to 0. So what we are doing is, if pi ij, then what is pi ijk? Now pi ijk is the immediate successor node of this. If we are going via k, then it will be k. If we are going ij, then we are coming to k, then we are coming to L, then we are coming to M, then we are going to j, then the immediate successor node must be printed because this will return an optimal solution. So what we are saying is, when there is no intermediate vertex, and there are the cases that if I equal to j, that is a self loop, or wij is infinity, there is no path, it will return nil. If there is some weight or I is not equal to j, it will be simply returning I. Now, why it is returning I? It means that if let's suppose there is an edge from 1 to 4, we must print 1. There is an edge from 2 to 5, we must print 2. There is an edge between 3 to 5, then we must print 3. So what we are doing is, if there is a diagonal values or there is no path, we simply return as nil. But initially there can be a no path, but after some intermediate vertex, we can have a possibility of a path via some k. If there is a weight, we simply return I, right? If k is greater than 1, now what we are doing is pi ijk. There are two things if we talk about this mathematical formulation. If we are saying that dij k minus 1 is lesser, then what we are doing is pi ij k minus 1 is the previous value. Right? What we are doing is minimum of dij k minus 1 and dkik k minus 1 plus dkj k minus 1. So what we are doing is, if this is minimum, then we are carrying a previous value. The same thing what we will do in pi ijk, we will carry a previous value pi ijk minus 1. And if this is minimum, then we will be returning a dkj value, that is pi kj. Hope you get this point. Now, this is an example. This is a famous example and is being asked in most of the AK2 examinations. Let's think about this. What we will first do is, we will simply make a D0 matrix. Now, while creating a D0 matrix, what we are doing is, now D0 is equal to Wij. Now, what is Wij? If I equal to j, then we simply saying 0 because there can never be a cycle. If I not equal to j and I comma j does not belongs to an edge, then we simply say infinity, or else this is a weight of an edge I comma j. So what we have done here is, if there is a directed edge from this to this, we simply represent it by the weights. If there is no edge, we simply represent it by infinity. If there is a cycle, we simply represent it by 0. After creating D naught, we can simply create pi naught with this. For pi naught, what we have said is, if I equal to j and I comma j does not belongs to an edge, then we simply write nil. Else we write I. So what we are seeing here is, we are getting nil, 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 and nil values everywhere. And we are getting this as I. This here I is 1, here I is 2, here I is 3, here I is 4, and here I is 5. So we will be building this D naught and pi naught matrix side by side. After preparing the D naught, let's move ahead for the D1. Now for D1, we will be taking reference of D naught. Now, why we are taking reference of D naught? Because our formula is Dij k minus 1, Dik k minus 1 plus Dkj k minus 1, minimum of this. So while preparing D1, we must take a reference of D naught. Same thing, while preparing pi 1, we must take a reference of pi naught. So what we will do first is, if we talk about simply, we copy pasted the first row and first column of D naught matrix. That is first row and first column of D naught matrix. First step. What does this mean? Here, 1 is, now D1 means 1 is the intermediate vertex. 1 is the intermediate vertex. Now, if 1 is the intermediate vertex, we have copied first row and first column of D naught. Because here 1 can, if we talk about this position, this is 1, 1, 1, 2, 1, 3, 1, 4, 1, 5. Here 1 is behaving as a source, not an intermediate vertex. If we talk about here, 1, 1, 2, 1, 3, 1, 4, 1, 5, 1, here 1 is behaving as a destination, not an intermediate vertex. Hence, we copied first row and first column. After doing this, what we will do is, if there is any infinity in the row, we copy that corresponding column from D naught. If there is infinity in a row, we copy column. Right? If there is an infinity in a column, we copied that row. Now, what we have to do, we have to compute these three values. While computing these three values, what we will do is this location, there can be an ij previous value, this is the infinity. So what we will do is infinity, comma. While calculating this value, this is ik and this is kj. Now what we are saying is, initially, if we talk about 4, 2, there is no path. But now we can see that 4, 2, 2, 4 to 1 and 1, 2, there is a path with 2 and 3. So what we will be saying, 2 plus 3, it will be 5. It simply returned as 5. While calculating this value, we will see the previous value of this, that is minus 5. Then ik is 2 and kj is this, so it will remain the same value. Now, while calculating this, we will see the previous value as this, infinity. And this value is 2 and this value is minus 4. We will get minus 2. Hence, we have noticed the change at two positions. So, what we will do, we will copy pi 1. In pi 1, we will copy pi naught, leaving these two positions. If we copy this, leaving these two positions, what will happen is we have to update this and this only. While updating this and this, what we will be getting is 4 say 2 is no path, 4 via 1 to 2 is a path. So what we will be returning is pi kj. That pi kj will be pi 1 2. Pi 1 2 0 will be returning, pi 1 2 0 will be returning you 1. So same what will be? It will be 1. Same if we talk about this 4 comma 5, there is no path 4 to 1, 1 to 5. So we will be returning pi 1 5 of 0. Pi 1 5 of 0 will be a 1. So this will be updated here as 1. Similarly, what we will do in D naught, D2, second column, second row, then if there is an infinity, we simply copy the column. If there is an infinity in the column, we simply copy the row and we'll compute the other values. After computing the other values, we will see notify the changes. And notifying the changes, what we will do is we will copy pi 1 in pi 2, escape the changes in D naught, in D1, D2. The changes in D2. After that, these changes will be referred to pi kj value, pi kj of 1, and we can simply calculate pi's. This is the same structure we will follow for D3, then D4, then D5, and this will be the solution which we are getting, and this is an optimized solution. This is solved by DP. Thank you.